Think about the world around us. Smartphones connect us instantly, allowing us to communicate, share and access information from anywhere at any time. Cars are becoming smarter and safer, equipped with advanced systems that assist in driving, navigation and even autonomous capabilities. Medical devices diagnose and treat with incredible precision, revolutionizing healthcare and improving patient outcomes. What drives this technological revolution? It's the tiny, ubiquitous microchip, a marvel of modern engineering. These marvels of engineering are the unseen brains behind countless devices we rely on every day. From our phones to our cars and even our medical equipment. They are the engines of the information age, processing and storing data, enabling communication and powering our digital lives. Without them, our world would come to a standstill. But have you ever stopped to wonder how these chips are designed? The process is a blend of art and science. The process is complex, intricate and fascinating, involving a symphony of skilled engineers working together, each contributing their expertise. It's a journey from abstract ideas to tangible pieces of technology, a testament to human ingenuity and collaboration. Every chip starts as a concept, a solution to a problem. In this essay, we'll delve into the world of chip design, exploring the different stages and the brilliant minds behind them. We'll uncover the challenges they face and the innovations they bring to life. Every complex project begins with a vision. In chip design, this vision is shaped by system architects. They are the master planners, the ones who define the chip's purpose, functionality and constraints. They take a high-level view considering factors like processing power, memory requirements, power consumption and cost. Imagine them as architects designing a skyscraper. They determine the building's purpose, its size and its features before a single brick is laid. System architects translate the needs of the end user into a technical blueprint. They define the chip's architecture, specifying the major building blocks and how they will interact. This blueprint serves as the foundation for the entire design process, guiding the work of all other engineers involved. Once the blueprint is ready, front-end design engineers step in. Their domain is the world of digital logic, the language of zeros and ones that governs the chip's operation. They translate the architectural vision into a detailed schematic, a complex circuit diagram representing the chip's functionality. Imagine them as weavers creating intricate tapestries, but instead of threads, they use logic gates, flip-flops, and other digital components. Front-end design engineers ensure that the chip's logic is sound, efficient, and optimized for performance. They write hardware description language, or HDL code, a specialized programming language used to describe the behavior of digital circuits. This code serves as the blueprint for the chip's internal workings, dictating how it processes data and interacts with the outside world. With the logic design in place, the focus shifts to the physical realm. This is where back-end and physical design engineers take the stage. They transform the abstract logic design into a tangible layout, defining the physical location of every transistor, wire and component on the chip. Imagine them as city planners, meticulously placing buildings, roads and infrastructure within a limited space. Physical design engineers use specialized software tools to place and route billions of transistors, ensuring optimal performance, minimal power consumption, and adherence to strict manufacturing rules. They consider factors like signal integrity, heat dissipation, and electromagnetic interference. Their work is crucial in transforming the digital blueprint into a manufacturable reality. Section 5. Leaving no room for error verification. Chip design is a complex process, and errors can be costly. That's where verification engineers come in. Their role is to ensure that the chip design is flawless, functioning exactly as intended. They are the meticulous detectives of the chip design world, relentlessly searching for bugs and inconsistencies. Imagine them as quality control inspectors, scrutinizing every detail to ensure the final product meets the highest standards. verification engineers use sophisticated simulation tools and techniques to test the chip's design under various conditions. They simulate real-world scenarios, pushing the chip to its limits to identify potential issues. They verify the logic, timing, power consumption, and other critical parameters, ensuring that the chip will perform reliably once manufactured. Section 6. From design to reality, the tape-out. Once the design has been thoroughly verified, it's time for a crucial milestone, the tape-out. This is a significant event in the chip design process, marking the point where the design is finalized and ready to be sent for manufacturing. This marks the transition from the digital realm to the physical world. The digital design, which exists as a complex set of data and schematics, will now be transformed into a tangible physical component. The chip design, now a complex set of layout files, is sent to a semiconductor fabrication plant, also known as a fab. These files contain all the detailed instructions needed to create the chip. This is where process engineers take over. They are highly skilled professionals who specialize in the various stages of chip manufacturing. They are the masters of the fab, overseeing the intricate and highly specialized process of chip manufacturing. Their expertise ensures that the design is accurately translated into a physical product. Process engineers work with incredibly precise equipment and materials, using photolithography, etching, and doping techniques to create the chip's intricate circuitry on silicon wafers. These techniques involve using light to transfer patterns onto the silicon and then chemically etching away layers to form the circuits. They monitor and control hundreds of process parameters, ensuring that each chip is manufactured to the exact specifications of the design. This involves constant vigilance and adjustments to maintain the highest quality and yield of the chips produced. Section 7. Putting chips to the test, ensuring functionality. After the chips are fabricated, they undergo rigorous testing to ensure they meet performance and reliability standards. This is where test engineers come in. They develop and execute test plans using specialized equipment to assess the functionality of each chip. Imagine them as doctors running diagnostic tests, checking the chip's vital signs to ensure it's healthy and ready to perform. Test engineers check for manufacturing defects, verify performance parameters, and ensure the chip meets all design specifications. They identify and analyze any failures, providing feedback to the design and fabrication teams to improve the manufacturing process. Their work is essential in guaranteeing the quality and reliability of the final product. Section 8, the final journey, packaging and beyond. Once the chips have passed testing, they are ready for packaging. This involves encasing the delicate silicon die in a protective package, providing electrical connections to the outside world. Packaging engineers design these packages, considering factors like size, thermal performance, and electrical characteristics. Imagine them as jewelers, carefully placing a precious gem in a setting that both protects and enhances its beauty. After packaging, the chips are shipped to electronics manufacturers worldwide. Supply chain engineers play a crucial role in this final stage, ensuring the smooth and efficient flow of chips from the fab to the end customer. They manage inventory, optimize logistics, and ensure that the chips are delivered on time and in perfect condition. Section 9, a symphony of innovation, the future of chip design. The design and manufacture of microchips is a testament to human ingenuity and collaboration. It's a field where science meets art and precision meets creativity. It's a symphony of expertise, with each engineer playing a crucial role in transforming an abstract idea into a tangible piece of technology that powers our world. Every step, from initial concept to final product, requires meticulous attention to detail and a deep understanding of both the science and the market needs. As technology advances, the demand for smaller, faster, and more powerful chips continues to grow. This relentless pursuit of improvement is what drives the industry forward. This demand drives innovation in the field of chip design. Engineers and researchers are constantly seeking new ways to enhance performance, reduce energy consumption, and increase the efficiency of these tiny yet powerful components. Engineers are constantly pushing the boundaries of what's possible, exploring new materials, architectures, and manufacturing techniques. They are not just solving today's problems, but also anticipating the needs of tomorrow. From artificial intelligence to quantum computing, the future of chip design promises to be even more exciting and transformative. These advancements will enable a new generation of devices and applications that will shape the future, making our lives more connected, efficient, and intelligent.